Space Station Comparison: China Tian Gong vs. ISS. ISS, the International Space Station, essentially a low Earth orbit research laboratory, is a joint venture between the 5 participating space agencies of the US, Russia, Japan, Europe, and Canada. Since the launch of ISS in 1998, for the past 20 years, for most of the time it was the only manned laboratory which locates in space. However, soon, the ISS and their crews will not be lonely anymore there. On April 29, 2021, China launched its space station core module Tianhe. 1 month later, on May 29th, China launched the Chen-Chota cargo spacecraft from Yunchang Satellite Launch Center on China's Hainan Island. Then the vessel completed the automated rendezvous with the Tianhe module 8 hours after blasting off from Hainan Island. The spacecraft carried supplies for a crewed mission expected to be carried out in June 2021. Today, we will compare the ISS and the Chinese space station, which is still under construction. Life cycle. To date, the ISS has been continuously occupied for more than 20 years, the longest continuous presence in low Earth orbit. The first ISS component was launched in 1998, and the first long-term residents arrived on the 2nd of November 2000. As of November 2020, 240 astronauts, cosmonauts, and space tourists from 19 different nations have visited the space station, many of them multiple times. When the ISS already running for more than 20 years, the Chinese Tiangong station has not finished construction yet. According to the overall construction task process, there still will be dozens of consecutive launches needed in the coming 2 years between 2021 and 2022. The mission will finally complete the total construction of the space station and put it into use in 2022. Capacity and volume. The major differences between ISS and the Chinese Tiangong will be the capacity and volume. Once fully assembled, the Chinese station will be roughly 1/6 the mass of the ISS. This means it is closer in size to Russia's retired Mir station. The ISS has a pressurized volume of approximately 1,000 cubic meters, a mass of around 420 tons, 100 kilowatts of power output, a truss 108.4 meters long, and modules length 74 meters. By comparison, the Chinese station will be approximately 388 cubic meters, a mass of around 66 tons, also approximately 100 kilowatts of power output, no truss structure, and modules length 47 meters. By size, the fully assembled Tiangong station will be similar to a Boeing 787 airplane. Building the complete ISS station required more than 40 assembly flights. In total, it took more than 10 years to complete the ISS. China hopes to complete its station within 2 years. The ISS usually hosts 6 astronauts at a time, but at some points, there have been more people on board. For example, a record was set in 2009 when a total of 13 people were on board the ISS at once. With approximately 1/6 the mass of ISS, the Chinese station was designed to accommodate 3 long-term crews and an extra 3 astronauts for a short visit. According to their current plan, it is estimated from 2023, 12 astronauts will be sent to the space station to complete various research tasks. The 12 astronauts will be divided into 4 batches, with 3 astronauts in each batch. The time for each phase will be 3 to 6 months. By structure, all the space stations in human beings' history can be categorized into 4 generations according to the structure. First-generation stations, such as Salyut 1 from the Soviet Union, had monolithic designs, consisting of 1 module with no resupply capability. The second-generation stations, Salyut 6 and Salyut 7 from Soviet or the Skylab from America, comprised a monolithic station with 2 ports to allow consumables to be replenished by cargo spacecraft. The representative of the third generation is the Mir space station, operated from 1986 to 2001 by the Soviet Union and later by Russia. The Mir station consists of more than 1 primary spacecraft and can be expanded with add-on modules. It could support a resident crew of 3 or larger crews for short visits. The Chinese Tiangong has a similar crew capacity with the Mir station. The ISS is the only project of the 4th generation space station. Compared with the 3rd generation, the major difference is the ISS takes the truss structure as the basic structure. The solar panels cabins are attached on both sides of the truss. Therefore, ISS is essentially different from the third-generation space station in which the cabins were directly assembled. The truss structure and the building block-like structure make it larger and more complex. The ISS is divided into two main sections: the Russian orbital segment and the US orbital segment. The US shares its segment with Europe, Japan, and Canada Space Agency. It has 16 cabins. For Russian cabins, 9 American, 2 Japanese, and 1 European cabin. As the largest international cooperation project to date, the International Space Station has cost member countries more than $100 billion in funding. And the Chinese Tiangong is designed to be still the third generation. Tiangong will feature 3 main components, including the core service module Tianhe that was launched in April 2021, as well as 2 laboratory modules Wenqian and Mingqian. Attached to these will be several other components, such as solar arrays and docking ports. Each module will be directly assembled to the core module through the docking port, which is a typical third-generation structure. To build the truss structure in the 4th-generation space station, the space shuttle is necessary. The ISS truss structure has been built by NASA before the retirement of the space shuttle. However, China has no plans for a space shuttle at the moment yet. This means the truss structure is not feasible for them shortly. On the other hand, the third-generation station is also more economically feasible, since the station is solely funded and constructed by China. What else? From the structure, mass, and manned capacity, Chinese Tiangong will be more closer to the Russian Mir station from 1986. Much smaller than the ISS. However, Tiangong will be equipped with some latest technology which may not inferior to ISS. ISS is equipped with more than 1 robot arm, the Canadarm, to help assemble, grow, and repair the ISS. The ISS also has a 2-armed dexterous robot called Dexter for delicate work outside, and a Japanese-built robotic arm for deploying experiments externally. Tiangong is also equipped with a mechanical arm. The robot arm can perform the function of cabin crawling and move to many parts of the space station in a worm-like motion. With this special design, it can reach the surface of each cabin in the largest range. What is more interesting is the Chinese station is designed to be equipped with an optical module named Xunqian. The telescope of Xunqian has an impressive 2 meters diameter lens, making it comparable to the Hubble Space Telescope. However, it boasts a field of view 300 times greater than that of 31-year-old Hubble, while retaining a similar resolution. To ensure the accuracy of its optical observation and avoid vibration interference when the space station is working, the telescope is not connected with the space station. It will co-orbit Earth along with the Chinese space station and will be able to periodically dock with the future crewed outpost. Cooperation involving 5 space programs and 15 countries. The ISS is the most politically and legally complex space exploration program in history. One of the most ambitious international collaborations ever attempted. The largest space station ever constructed. The International Space Station program brings together international flight crews, multiple launch vehicles, globally distributed launch, operations, training, engineering and development facilities, communications networks, and the international scientific research community. As of November 2020, astronauts from 19 different nations have visited the ISS. Includes 152 Americans, 49 Russians, 9 Japanese, 8 Canadians, and 5 Italians. However, China's astronauts are not allowed aboard the International Space Station, even though it's one of just 3 countries that runs its own manned space program. This is because parts of a 2011 law prohibit NASA from using any of its funds for cooperative projects with China. Various government reports since the law went into effect have claimed China's space activity as a threat to U.S. political and military security. On paper, the life expectancy of the space station is 15 years. Over the past few years, the life expectancy of ISS has been extended to 2020 and then 2024. Boeing, the primary contractor for the ISS, is in the midst of a feasibility study to see if the station could survive until 2028. The weak point is the solar panel. After 20 years in space, the solar panel's efficiency was much lower than design. Boeing has an idea to overlay the old panels with newer, more efficient cells, should the need arise. The China station has an expected lifespan of 10 years it could be extendable with proper maintenance. And the designs of modular space stations provide greater flexibility. The interesting thing is, although the station will be 1/6 of the mass of ISS, China has adopted a new type of flexible solar cells. The total power generation is almost equivalent to the ISS. The power supply gives the potential to meet the extension of the cabins in the future. So the questions for the future space: whether ISS will keep running till 2028, whether China can fully assemble the Tian in the next 2 years, whether China will manage to put the station into use in on time, whether Tiangong will be the only running station for the future space. That's all for today, and thanks for watching.